Today we're going to be graphing quadratic formulas from standard form. Standard form, you have ax squared plus bx plus c. So the following problem, you have a value of 1, a b value of 4, a c value of -12. A is the first number, b is the second number, c is the third number. This formula right here is for line of symmetry. So, to find line of symmetry, you do x equals negative b, which is -4, over 2 times a, which is 1. If you have a hard time remembering this, it's the opposite of b over 2a. That might help. So this is -4 over 2, which is -2. That's my line of symmetry. So I'm going to come down here and draw a dotted line on -2. So this is x equals -2. My vertex actually lies on my line of symmetry. So to get my vertex, I need the y value of it. So I'm going to plug in -2 into the formula. So this is -2 squared plus 4 times -2 minus 12. That gives me an answer of -16. So I'm going to go down here on my dotted line and put a dot at -16. So this dot right here is my vertex, which is -2, -16. That's the vertex. Okay, so we have done this box, and I'm going to write C graph. Okay, the next thing that I have to do is to find my solutions. And the way you find your solutions is by factoring. So we have x squared plus 4x minus 12 equals 0. So to factor, you look for the factors of 12 that are going to give me 4. And that's going to be +6, -2. So my solution is x equals -6 and x equals +2. Since those are x equals, those go on the x-axis. So I'm going to go to 2 on my x-axis, and I'm going to go to -6 on my x-axis. 2, 3, 4, 5, and -6. So this is x equals -6 and x equals 2. So now I have my 3 dots, and to get my graph, all I do is connect my 3 dots with a smooth curve, and it's always a curve because it's a parabola. Now, my domain for any quadratic function is, my domain is all real numbers, so that's -infinity to +infinity. My range, though, is from the vertex, which is -16, to +infinity. Okay, let's do one more. Up here you have A is -1, B is 2, C is 15. So, to find the line of symmetry again, I do x equals -b, which is -2 over 2 times -1, which is my a value. So this is going to be -2 over -2, so my answer is 1. So I'm going to go to 1 on my graph and do a dotted line straight down. So x equals 1. Now, I'm going to plug 1 into my equation so that I get the y value of my vertex. So -1 squared plus 2 times 1 plus 15 gives me a value of +16. So I'm going to go up here on my graph, and I'm going to put a dot right there, and that is 1, +16. So I've done this, I've sketched the, and I've plotted my vertex. Okay, so now we have to factor to find the solutions. -x squared plus 2x plus 15 equals 0. I have a leading negative, so I'm going to factor out my -1, which changes the signs of everything in that polynomial. So now I have a polynomial that can be factored. Factors of 15 that give me 2 are 5 and 3. The 5's negative, the 3's positive. So when I solve, I get x equals 5, x equals negative 3. So I'm going to go over here and put a dot at negative 3. X equals negative 3 and a dot here at 5. 2, 3, 4, and 5. X equals 5. If you notice, your axis of symmetry is always in between your two solutions. The only thing this negative 1 tells me is that the graph opens down, and when we connect these three dots, you will see that my graph is opening down. So my domain, again, is all real numbers, which is negative infinity to positive infinity, and my range is negative infinity to positive 16. Okay, so I hope this helped you with graphing trinomials.